Now let's talk about a system of linear inequalities. So remember in the last video, I said that the solution is the point or points that make all equations or inequality true. Well, when we have a system of linear inequalities, our solution is going to be the set of points, and you are definitely going to have more than one. You're going to have a ton of points, or you can have a ton of points, like lots, like millions. Set of points, and I'll show you, that make all inequalities in the system true. So we're going to look at example 2. We're going to sketch, but this is algebra 2. I know you guys know how to graph lines. So actually we're not going to sketch. We're going to graph this on our calculator, but to be able to graph it on your calculator, yeah, some calculators let you type it in like this, but it's still good practice to rearrange this into slope-intercept form. So let's take this equation, solve it for y. So I'm going to subtract the 2x on both sides. So this, I call it an equation. It's an inequality. Subtract 2x on both sides. We'll have y is less than or equal to negative 2x plus 14. So that is one inequality that's going to be graphed. And notice that it's less than or equal to. So whenever you're solving system of linear inequalities, it does involve a graph. And whenever you see a less than or equal to or greater than or equal to, you want to use a solid line. Because a solid line indicates that you want to include the points on that line. If instead of or equal to parts, it has just less than or just greater than, you're going to use a dashed line. And a dashed line indicates that you do not want to include the points on the line. All right. Okay, so now I'm going to rearrange my second inequality. I'll subtract x on both sides and get 2y is less than or equal to negative x plus 10. Then I will divide every single thing by 2. And I'll have y is less than or equal to negative 1/2 x plus 5. So I need to graph this inequality. And I need to graph the one right here written in black. And then I need to also graph x is greater than or equal to 0 and y is greater than or equal to 0. So we're going to get our graphing calculator, in other words, our graphing computer. Oops. Here's what we'll do. I'll just hide that part. I'm going to bring Desmos over here so you can see it. I don't want to minimize it. Okay, so I'm going to graph y is less than or equal to 2x plus 14. And notice they have used a solid line and shaded the region. Now I'm going to change the color here because I want it to match my color coding. Okay, then I'm going to graph y is less than or equal to negative 1/2 x plus 5. And I'll change the coloring again because I want it to match. Okay. Then I need to graph x is greater than or equal to 0. And I also need to graph y is greater than or equal to 0. And this needs to be blue. Okay, so I have a really colorful picture here. Lots and lots to look at. Let me zoom out a little bit more. Okay, so it might be helpful if I look at what got graphed in order again. So let me ungraph these first. Because when you're looking for the solution of the system, you want to look where all of these shaded regions overlap. So the first one was gray. So this region right here is a set of points, and it's actually shaded because the shaded represents an infinite amount of points. So all of these points make this black inequality true. Like if I were to put 10, 0 and substitute in for x, it makes this inequality true. Okay, so far that's our solution. But then when I add the second inequality, I now have a part where they overlap. Now the part where they overlap is the solution for these two. But now I'm going to add x is greater than or equal to 0. So notice now I just have the part in the first quadrant where they overlap. So far, let's see, can I write right here? So far, the part where all three of them overlap is right here, this triangle. And then I need to add, oh wait, hold on. X's, yeah. Actually, they all overlap right here. All of this part is where they all overlap. Okay, but then as soon as I add the y is greater than or equal to 0, then I just talk about the first quadrant. So I'm going to erase what I colored in. So now all four of these overlap in this little triangle right here. So that means that this triangle is my solution region. Any point in here will make all four of those inequalities true. Don't believe me? Let me prove it to you. I'm going to have to color some more. So delete this. Move this over. Okay. Oh, zoom out just a little bit. Okay. So anything in this triangle where all four of them overlap should make all four inequalities true. So randomly, when I say randomly, I'm going to pick this point in here. That's the point 4, 2. Okay. Well, does 4, 2 make this first inequality true? Well, if x is 4 and y is 2, I would have 4 times 2, which is 8, and 8 plus 2 is 10, and 10 is less than 14. Yes. Does 4, 2 make the second one true as well? Well, 4 plus 2 times 2 is 8, and 8 is less than 10. Ooh, that makes that true. Is 4 greater than 0? Yes. Is 2 greater than 0? Yes. So the point 42 makes all four of those inequalities true. All right. Now, if you feel like you've got a good handle on this, go ahead and skip to the next video. Otherwise, I'll work out a couple more examples. Oh, sorry. We can do number 21. Didn't realize I was still recording. We can do number 21 on page 46. So I need to simplify each of these and get the y by itself. So y is less than, subtract 2x on both sides, negative 2x plus 10. Then I'll graph, I can subtract x on both sides to get negative 2y is less than negative x plus 8. And I need to divide everything by negative. But remember, anytime you divide or multiply by a negative and you're working with inequalities, you need to switch the way that inequality faces. So make sure it switches. So now we have y is greater than positive 1/2 x, and I'm dividing by negative, minus 4. Then I'm going to graph x is greater than 0, y is greater than 0. So let me come over here and graph my inequalities again. So y is less than negative 2x plus 10. Notice they are graphing a dotted line, less than. Then I can also graph y is greater than 1/2 x minus 4. And so now I see that this region is overlapped. And x is greater than 0 and y is greater than 0. Here's a tip. I can graph those again, but I'll get a really shaded picture. When x is positive and y is positive at the same time, you're in the first quadrant. So the total solution is everything in the first quadrant that overlaps the red and the gray area here. So this part is my overlapping my solution to everything.